All right, so we are talking about volume now. So before we were talking about surface area and lateral area. That's covering a shape. Volume is what fits inside of a shape. So like inside of a can, like inside of a cereal box, inside of a soda can, inside of a Pringles can, what fits inside of it. So that's what we're finding now, is how much we can fit rather than covering a shape. All right, so the first thing is the definition, and that is volume. And volume is the amount of space inside a solid, okay, what you can fit inside of it, that's volume. Area is outside, covering, like wrapping it with wrapping paper. Volume is what we can fit in. And the volume of a prism is the area of the base times the height of the prism, okay? Now, you'll notice I put the little area formulas up there for you so that we have those to use once we get to different bases. That's not anything, again, you need to memorize. I will give them all to you, but we've got a triangle, rectangle, square, parallelogram, trapezoid, and circle. All of those formulas are there for you to refer to. And then we're also going to talk about finding the volume of a cylinder. And the formula for that is pi r squared times h. Remember, r is your radius. The h is the height of the cylinder. Think how tall your soda can is. Okay. So a prism, the area of the base times the height of the prism, how tall it is. So if you look at our first shape, what is the base? What shape? Rectangle. Okay, so what I want you to do first is looking at the bottom of that picture. Look at that bottom rectangle and find the area of it. And looking at that rectangle, the bottom of it, we want to find the area. The formula for your area is right there on the top of your page. The formula for area of a rectangle is length times width, correct? All right, again, we're looking at this bottom rectangle down here. What is the length of that rectangle? The one I just drew in red, what's the length of it? 17. And what is the width of it? 9. Okay, so we're finding the area of that base first, which is just 17 times 9. How much? Is it good? Then to find the volume, we're going to take the area of that base and multiply it by the height of the prism. How tall is that box? 24. So we're going to take 153 and we're going to multiply it by 24, and that's going to give me my volume. Okay, 3,672. So that is the answer that we're looking for.
That's all you gotta do?
Yeah. Make a little bit of sense?
So for the next one, you're gonna do 14 times 10.
Yep. Everybody go ahead and try 2. Actually, go ahead and try 2 and 3. I'll give you a couple minutes to do that. Find the base, find the area of it. These are all rectangular prisms, so find the area of your rectangle, and then multiply by the height of the prism. Technically, with a rectangular prism, the volume is length times width times height, okay? But we need to get in the habit of finding the area of the base because our bases could change. However, in a rectangle or a rectangular prism, it really isn't that important that we do that. It is just the length of the box times the width of the box times the height of the box. Are we using this bottom one for our base on number 2? This one down here? Okay. What's the area of that? Yeah, so it would be 14 times 10 to give me 140. And then to find the volume, I'm just going to multiply that by. And did y'all get 630? Okay. Now with number 3, I would probably use
39 and 12, right?
You can.
Doesn't matter. It's
It-
gonna be the same.
It doesn't. You'll get the same answer.
I would use the ones with all the four right triangles.
With the 4, yeah. So you can use that one. We can go back and do that. We can use this one. So to find the area of that, what did y'all do? 12 times 39? Okay. That's going to be 468. And then I'm going to multiply that by 8.
That's all you gotta do? You still got 3,744. It should be.
So far, so good?
Yeah.
Rectangular prisms are not hard.
Oh, it's different for the two.
Everybody ready? Let's flip over. These are going to be slightly different because my base has changed. However, we have the formulas that we need. Here's the question. What shape is my base in both times? Triangle. Okay. So we're going to have to focus on the triangles to find the area of those. So I'm just going to refresh. It's on the back, the other side of your paper. But the formula for area of a triangle is 1/2 the base of my triangle times the height of my triangle. Not the height of my prism, but the height of my triangle. All right, so let's focus on our triangle. Does everybody see? I'm going to highlight it. This triangle down here in the bottom. Now, the base and the height in a triangle are the two segments that are perpendicular to each other. Does everybody see a perpendicular segment in that bottom triangle?
Yeah.
What is the length of the height in that triangle?
10 and 15.
In the bottom, in the highlighted portion. The height has to be perpendicular. 7.3, okay. Whoops. Sorry. I'm going to use parentheses to separate my numbers here, okay? Still just multiplying. So again, in my triangle, my height is the one that is perpendicular, and it is perpendicular to my base, which is this segment right here that I'm highlighting in red. Does everybody see the one I'm highlighting in red right now? What is the length of that one? Okay, the 5 is going up and down. Hold on. Okay, so the 9 is this segment right here. Everybody see where I'm pointing to? The 5 is this segment. The 10 is that segment, which means it's that segment. So what would it have to be? 12. Okay, remember that's a rectangle there, so that's going to be that part. So the base of my triangle is 12. So what I want you to do in your calculator is do that. Do 1/2 times 12 times 7.3. Okay, so I have a base area of 43.8. And again, the volume is the base, the area, times the height. Do you see how I'm using a big B and a little b? The little b is the base of the triangle. The big B is the area of the base. Now, the height of my prism is how far it is between the two bases. I have a triangle on the bottom. I have a triangle on the top. How far is it telling me the distance is between the two? Look at your picture. We have a triangle on the bottom. We have these numbers, we haven't used 9, we haven't used 10, and we haven't used 5. Which one of these is the distance between this top triangle and the bottom triangle? 5. Okay, this is the distance between my two bases. Everybody see that? So, I'm going to plug in my numbers, 43.8 times 5. And that's going to give me 219. Everybody kind of okay with that one? The triangle ones are harder to see, but what you have to try to visualize is what that would look like in real life. Okay, think about like a slice of cake. Okay, you have your bottom triangle and you have your top triangle. The height is how tall that cake is. That kind of looks like a piece of cake, right? No? You can't see a piece of cake at number 4?
I mean, I could, I know, but you really look to the left.
Okay. Now, number 5, my shape is turned different. My shape this time is turned on its side. So can you tell by looking at this picture that the triangle is in front and back? Does it look like that to you? Yes?
Yeah.
Do you see a triangle in the front of the picture?
Mm-hmm.
Okay. We're going to find the area of that triangle first. What is the base of that triangle? What is the segment that is perpendicular to the height of the triangle? 5.4, that's the height, yeah. So what's perpendicular to that? 11. So 11 would be my base. 5.4 would be my height. Okay, my base is here. My height is here. They are perpendicular to each other. And we're focusing on that triangle there in the front. What is 1/2 times 11 times 5.4? Whoa. Then we're going to go to volume. Again, that's the area of the base and the height of the prism. The area of the base we said was 29.7. What is the distance between this front triangle and the back triangle? 6 or 6? Here's your front triangle right here. Here's your back triangle. What is the distance between the two? 16. 16 is going to be the height of that prism. Okay, let me show you. Let me try to. Again, it's hard to imagine sometimes these 3D shapes. Here's my front triangle. Here's my back triangle. Do you see how the only number that I haven't really touched besides the 5.4 is 16? 16 is the distance between those two triangles. Does that kind of help visualize a little bit? Maybe, sort of.
Yeah.
So we're going to get 475.2.
Can we go back to how we do it, like in the front?
If we get another rectangular prism, yes. Are we kind of okay there? You got to focus on the triangle and then find the distance between the two triangles.
Oh,
Let's take a look at 6.
man.
I'm going to try to break this one down for you by drawing it separately, see if that helps. What shape is that at the front? It looks like this. Yes, trapezoid, okay? Okay, so this is 14, correct? What would this top segment be right here? 36, okay. And then we have that height that's drawn in right here. What is that, 17.9? Can't see that far. Does everybody see the trapezoid in that picture? So, formula for area of a trapezoid, again, that's on the front side. It is 1/2 the height of the trapezoid times the two bases added together. Okay, again, I don't expect you to memorize those. You will have a sheet with all of these formulas on it. Okay, again, we're not focused on any other parts of that picture right now besides the trapezoid. Let's plug our numbers in. What is the height of my trapezoid? 17.9. And then I'm going to multiply that by my two bases added together. The bases are the sides that are parallel. What would the lengths of those be? 36 and 14. Does it matter if I put 36 plus 14 or 14 plus 36? No. All right, so what I want to do first before I go to my calculator is let's add those two together. 14 plus 36 is going to give me 50, I believe. Now we can do our work. 1/2 times 17.9 times 50 is going to give me a base area of 447.5. 1/2 times 17 times 50. Did everybody else get that in the calculator? So far, so good? Now, looking at the picture, what I need to do is, what is the distance between the two trapezoids? That would be this distance here. Okay, now I don't have anything labeled down at the bottom of the picture, but what do I see that's in the same direction in that picture? 25. Okay, so 25 is going to be the height of the prism. That's the distance between the two bases. So we can finish this now by doing my volume is equal to the area of the base, which we just found is 447.5, times the height of the prism. That's the distance between the two trapezoids there, which is 25. And I get a big number here. Did y'all get 11,187.5? 447.5 times 25? Somebody push some buttons in the calculator. Tell me if you get the same number. Yeah? So when we have these shapes that are not rectangular prisms, because those are super easy, and the cylinders are actually super easy. It's anytime I change the base to a triangle or a trapezoid, it's going to require a little bit more work. You've got to try to zone in on that particular shape, like specifically the triangle or the trapezoid, and then try to tell the distance between the two. A lot of the times they're going to give us a lot of extra numbers that we don't need. Okay, so you've got to just try to focus as much as you can. Okay, so just trying to find my pointers. I could read. Okay, so do you see? This is my trapezoid right here, and then there's another trapezoid back here. So from this front trapezoid to that back trapezoid, it would be one of these lengths here. And that's the distance between the two bases. The distance between the two trapezoids. Yes. Yeah. Sometimes it's turned on it, like this one is it's turned on its side, so it doesn't look like the height, right? But it's the distance between the two bases. That's your height of a prism. Is everybody kind of okay? Real good with the rectangular prisms? Those were easy. Triangular and trapezoid prisms are a little bit more difficult. Now let's move to a cylinder. Again, easy because I just have to plug some numbers into a formula. So we said for a cylinder, the formula for the volume is pi r squared times h. Okay, and again, in a cylinder, these are not too terribly difficult because I have everything I need usually. What's the radius? 18. Okay, so we're going to plug that in. And then what's the height? What's the distance of between the two circles? 15. So I need you to do 18 squared times 15. And then we're going to stick pi on it. And leave our answer just like that. $4,865. Yes, no, maybe. You good? You understand that one? Okay. All right, try 10. You don't have your radius though, so you're gonna have to figure out your radius first. This time you're given the diameter. So find the radius, then plug it into your formula. Pi r squared times height. So figure out your radius, decide what's your height, square the radius, multiply it by the height, stick pi on it. All right, if my diameter is 11, what is my radius? 5.5. Okay, we take 11 and cut it in half. What's the height of this cylinder even though it's laying on its side? 21. Okay. So in your calculator, square 5.5. Then multiply that by 21. $635.25, and we stick our pi on it. Rectangular prisms are easy. Cylinders are easy because you really mostly have everything you need. You just plug them into the formula. Okay? It's when we get to the triangles and the trapezoids that it becomes a little bit more difficult. Okay, read that question. This is the last one. You got a picture to the right. A cylinder with a 2-centimeter diameter is drilled through the triangular prism shown. Oh, I don't want you to find the volume of the prism. Let's find the volume of the cylinder. I'm not going to make that too terrible. That would be way too hard. Okay. I can't spell cylinder. Find the volume of that cylinder that is inside of that prism there. I'm not going to make you do let's just find the volume of what was drilled out there, that cylinder. It tells you the diameter of the cylinder is
1 or 2.
2, so that means the radius would be 1. And then what is the height of that cylinder? 14. Again, volume equals pi times radius squared times height. You just told me my radius was 1. You told me my height was 14. So what would the volume of that cylinder that we drilled out be? 14 pi. Now, if I were to try to find the volume of what's left, because they may throw one of these at you on the EOC, you would find the volume of the whole cylinder, the whole prism. You would find the volume of the cylinder and you would subtract the 2 is how you would do it, like taking a piece out of it. But I'm not going to make you do that, and I'm not going to make you do that on a test either. Everybody okay? Any questions? All right.